In this video, we're going to look at solving equations with algebraic fractions. And in this first video, we're going to focus on equations that give us linear equations to solve. So first of all, let's remind ourselves of how to work with a fraction in an equation. So if we have 3x over 5 equal to 9, then what we have to do is multiply by 5 on both sides, leaving us with 3x equals 45, and then after that we divide by 3 on both sides to get an answer of x equals 15. So when we have a fraction in an equation, we always multiply by the denominator to remove the denominator. And that's going to be a principle that we use in solving equations with algebraic fractions in. So generally speaking, if there is a single algebraic fraction, that's all we do. We multiply the denominator to remove it. If there's more than one algebraic fraction in the equation, then we add or subtract to combine those algebraic fractions so that we only have one, and then we do the same thing. We multiply by the denominator to remove the algebraic fraction. So let's look at some examples. In this one we have two algebraic fractions being added together. So the first thing we have to do is combine those algebraic fractions. So let's move this over here a little bit, and what we're going to do is we're going to get a common denominator, which in this case is going to be 10. And we had to multiply the 2 by 5, so we have to multiply the top by 5 as well, giving us 5x. And we had to multiply the 5 by 2, so we have to multiply the 3x by 2 as well, giving us 6x in that fraction. And then this is all still equal to 22. At the moment we're just simplifying the fraction by adding it together. Next step is to add those together. Remembering now we have a common denominator, we can just add the tops. So we get 11x over 10 equals 22. And now we can multiply by 10 on both sides, which gives us 11x equals 220. And finally we can divide by 11 on both sides, which gives us x equals 20. That's our final answer. So all we did was add together the two fractions and then solve with the single fraction by multiplying by the denominator. In this example we only have a single algebraic fraction, so we're going to go straight into multiplying by the denominator. So the first thing we want to do is multiply by 6 and multiply by 6. That gives us 15x plus 15 equals 60. And then if we take away the 15, we get left with 15x equals 45. And finally we divide by 15 on both sides, and we get left with x equals 3. In the rest of the examples I'm going to say, but I'm not going to write the steps that we've done on each side. Okay? So the next example, we have 3 brackets 2x minus 5 over 4 equals 6. Once again there's only a single algebraic fraction, so the first thing we're going to do is multiply by 4, and we get 3 2x minus 5 equals 24. Now we can expand the brackets and we get 6x minus 15 equals 24. Add the 15 and we get 6x equals 39. And finally divide by 6 gives us x equals 39 over 6, which is equal to 13 over 2 or 6.5. So either of these last two would be fine. Now in this example we have two algebraic fractions, so we're going to have to combine them first. So the first thing we're going to do is combine these by adding them together, and for that we need a common denominator, which for 3 and 4 is going to be 12. So we fill in our common denominator and it's still going to be equal to 3. For this first one we had to multiply by 4, so we have to multiply by 4. So that gives us 4x minus 1. And for the second one we had to multiply by 3, so we have to multiply the top by 3, giving us 3x plus 4. Now we combine the fractions and we get 4x minus 1 plus 3x plus 4 all over 12 is equal to 3. Now we can either simplify the numerator first, or we can get rid of the fraction first. It doesn't matter which we do. I'm going to get rid of the fraction first so that we have a nicer equation to deal with. So we have 4x minus 1 plus 3x plus 4 equals, multiplying by 12 we get 36. And now expand the brackets, we get 4x minus 4 plus 3x plus 12 equals 36, which gives us x plus 8 equals 36. Sorry, that's not x there, is it? It's 4x plus 3x, so it's 7x plus 8 equals 36. Minus the 8 gives us 7x equals 28. And finally, divide by 7 gives us x equals 4. And that is our final answer. In the next example we have a similar thing, but this time it is a subtraction. So we're going to do the subtraction first. We get the common denominator first, which is 15. And that is still all going to be equal to 3. We multiply the 3 by 5, so we have to multiply the top by 5, giving us 5x plus 3. And we multiply the 5 by 3, so we have to multiply the top by 3, which gives us 3x minus 4. And now we are going to combine the two fractions into one, so we get 5x plus 3 minus 3x minus 4 all over 15 equals 3. Again, we can either simplify or get rid of the fraction first, it doesn't matter which. I'm going to get rid of the fraction, gives us 5x plus 3 minus 3x minus 4 equals 45. Expanding the brackets, we get 5x plus 15 minus 3x plus 12 equals 45. Simplifying that, we get 2x plus 27 equals 45. And now we get 2x taking away the 27 equals 18, and finally x equals 9. We have two more examples to look at, so let's move on to those. This one is slightly different in that it doesn't have a sum. It has two algebraic fractions, but they are separated by the equal sign. But what we're going to do is exactly the same. We're going to move one of them over to this other side so that we can do a subtraction. So the first thing we're going to do is 3x minus 3 over 7 minus 2x plus 5 over 5 equals 0. So all we've done is subtract this fraction from both sides. And now we've got an equation that looks similar to the other ones we've seen. And we're going to find a common denominator, which in this case is 35. And it's all equal to 0. And this time we times 7 by 5, so we have to times the top by 5. Now when we multiply 3 brackets x minus 3 by 5, we just multiply the 5 by the 3 on the outside, which gives us 15 x minus 3. And in the second one we multiplied by 7, so we have to multiply the top by 7. And again, multiplying the whole lot by 7, just multiply the outside number, the 2, by 7, gives us 14 2x plus 5. We're well on our way now, so we combine the two fractions, so we get 15 x minus 3 minus 14 2x plus 5 all over 35 equals 0. We get rid of the fraction by multiplying by 35. In this case, multiplying by 35 does nothing to the other side because it's timesing by 0, so we get 15x minus 3 minus 14 2x plus 5 equals 0. Expanding the brackets, we get 15x minus 45 minus 28x minus 70 equals 0. Now, cleaning that up a little bit, we're going to get minus 13x minus 115 equals 0. So this isn't going to simplify nicely. We're going to get a fraction answer here by the looks of it. So we get minus 115 equals 13x, which means that x is equal to minus 115 over 13. And that's our answer. Not a nice answer, but it is a fraction, and sometimes that's what we get. We don't get nice whole numbers, sometimes we get rather nasty looking fractions out of these questions. Okay, on to the last example, which is again a little bit different, but in many ways the same. It has 3 fractions in it, that's the only difference, but we're going to deal with it in exactly the same way. And just like with the last one, where we had one fraction on the other side of the equal sign, we're going to subtract that fraction first. So we're going to get 3y minus 4 over 2 minus 2y plus 1 over 5 minus 1 minus y over 3, and all of that is equal to 0. Now we need to find a common denominator. The common denominator for 2, 5 and 3 is going to be 30. So we're going to be over 30 and over 30 equal to 0. For this first one we have to times by 15, so we have to times by 15, so we get 15 3y minus 4. For the second one we have to times by 6, so we have to times the top by 6, so we get 6 2y plus 1. And for the last one we have to times by 10, so we have to times the top by 10, and we get 10 1 minus y. Now we just carry on in exactly the same way, combine them all into one, we get 15 3y minus 4 minus 6 2y plus 1 minus 10 1 minus y all over 30 equals 0. We're nearly there now. We need to get rid of that fraction, so we multiply by 30, leaving us with the numerator on the left hand side and on the right hand side 0 times 30 is just 0. Now we've got to expand all these brackets. We get 45y minus 60 minus 12y minus 6 minus 10 plus 10y equals 0. 45y minus 12y plus 10y is going to give us 43y, and minus 60 minus 6 minus 10 is going to give us minus 76, and that's all still equal to 0. So we get 43y is equal to 76, and y is equal to 76 over 43. Again, not a nice whole number, but a fraction, an improper fraction at that, but that is perfectly acceptable. And that's how we work with algebraic fractions in equations. We combine them by adding or subtracting, which we have seen before, and then we solve the single algebraic fraction by multiplying by the denominator.